All right, ladies and gentlemen, on the next assignment C in chapter 3, we're going to look at more how to use a compass because we're actually going to take a look at using multiple vectors and adding them together. And this is going to be probably the most complicated part of this chapter. And so with this, purpose of this lecture is to learn how to work in degrees and use a component of the vectors to determine the resultant. And we're going to do 2 or more vectors with this. And when we're doing most of these problems deal with distance, going so far with a certain direction. Now we can place the distance or the displacement with velocity, with acceleration, any other physical value that can have a direction associated with the magnitude. So remember this, if you see velocity, you can still use it as a vector. So the procedure is that you're going to take a starting point, you're going to draw a small compass, and then go from that first direction traveled. So basically, draw a small compass road, basically X across, so it looks like this, and let me get my pen started. So what I mean by this, draw a small cross. And then you're going to figure out what direction we're going to go. It may be up to the right or down to the left, first, second, third, fourth quadrant, it depends. So you got this vector that's going across, and I'm going to draw another cross. And then we're going to change the direction based on what the word problem says. And you're going to label the magnitude. So if we got a vector going this way, this is going to be 50 and this is going to be 25. And so we've got to make sure we label the vectors. Now these are all relative. Make sure the 50 is bigger than the 25 and so forth. It's going in the right direction. The actual angles does not have to be accurate. Just relative, just in the ballpark. Because honestly, we're having trouble, trying to draw these accurately. It's going to take a little bit too much time. And if there's further travel, you repeat this. So if we have we've got another vector, we draw that, and it's going to come down this way. And basically we try to find this resultant. This is going to be 45. So we figure out all these vectors, and we figure out where this is going. So our resultant is from here to the end. And this is our resultant. And that's what we're trying to find out. And you need to know the direction. How many degrees, in this case, south of east, are we going? And so, again, as a review for adding vectors, and they are not perpendicular to each other. We need to find the components of each one, then sum of the components, all the x's and all the y's, and then the resulting vector is the sum of those x and y. The resultant is the sum of the x and y vectors. So we're going to be doing a lot of triangles. And this is where it gets complicated because, so I'm going to do this, and then we're going to draw another one going this way, a little bit longer, and we're going to draw another triangle, and it's going to go like this. And our resultant here's our starting point. It's going from the starting point to the end point. And we want to know what this is. And to do that, we need to figure out this vector, this component of our resultant, and this component. And to do that, we got to know what these components are. And so if you have 3 vectors, you're going to have 3 sets of x and y that you're going to have to add together to get this component vector and this component vector. It's not complicated. Well, it's a lot of work. Keep it simple, work in parts, and you should be able to get this done. And if you want to individually work on each triangle, you can. So if you want to work on this triangle first, figure out the x and y, then do this triangle next and figure out the x and y, you can. I don't care how you do it, as long as you get this resultant to be perfect. And that's what I want to know. All right, so in this case, we got a simple walk in the park, and we got 2 vectors. And in this case, we're going to we'll keep this in kilometers, I hope. Yeah, I know somebody's been getting after me about problem set B. I forgot to change one of the answers into kilometers. So I kept it in meters per second. I apologize for that. So here's the Boy Scout and his tent. He's walking in a direction of 55 degrees. And this is going to be 1.5 kilometers. So that's the total distance he has taken. And this angle is going to be 55 degrees. Direction of 55 degrees. And let me rephrase that. This is going to be 55 degrees because this is, remember, north is 0, and then he's going to go x at 55 degrees. So this is his first vector. And so if we do this, and we can do it this way, this is x, this is y, this is going to be 55 degrees, and the hypotenuse is 1.5. His next step is he's going to hike 3.1 kilometers in a direction of 290 degrees. So here's drew another compass rose, 270, so 295 is going to be in this direction. So my second vector is off in this direction. This angle, we need to know because this is my x, here's my y. Think about it. This angle here is not 295 degrees, but 295 minus 270. Because going directly west is 270 degrees, so we have an angle of 25. So this is my angle of 25. A lot of the problems that we have that are in the textbook is actually telling you degrees north or west, which is what this is, or east of north, which is what this is. So it depends on how the book states it. It can be stated both ways. Now let's go ahead and calculate the resultant vector. So we're going to do this in parts. So the first part, you're given a direction, and it's 55 degrees. So from 0, I'm going to draw the x component and the y component. This is 1.5. This is 55, and of course we're going to find x and y. So sine of 55 is equal to the opposite, which is in my case y, over 1.5. So to figure out my y, you take 1.5 times the sine of 55 degrees. And I'll get my calculator out for you guys. So I'll go sine of 55 times 1.5. I'm going to get basically a value of 1.23. If you want to go 1.228, that's fine too, but nothing more than 4 significant digits. So there's my answer for y. Now x is adjacent, so cosine of 55 is equal to x times 1.5. And so it's 1.5 times the cosine of 55. And that gives me my x. And that's going to be 0.86. So that's going to be this is kilometers. So this is going to be my x vector, and this is going to be my y vector. So let's do the second part. So again, my second part is actually going in this direction. Direction of 295 degrees, and I'm going to draw this vector. This is 270, excuse me, and we're going 295. So this is going to be 25 degrees, like I said earlier. So we need to know again the x and the y of 25 degrees. So here's the thing. You're going to get positive values for both x and y, but we know that x is going to be negative because it's going towards the left. So opposite is going to be sine of 25 it's going to give me my y direction. Y over, and I believe that answer is going to be 3.1. So sine of 25 times 3.1. That's going to give me 1.31 kilometers. That's going to equal my x. Excuse me, my y. I'm going to do the same thing with cosine. So the cosine of 25 is equal to x over 3.1. That's going to give me 3.1 times the cosine of 25. And that's going to give me, if I do the calculation, 2.81 kilometers. So we got two x's and two y's. Now, on this is going to have to be negative because I'm going left. Even though the value you're going to get is positive, you got to remember which way you're going. And this is probably the one that gets everybody, that trips everybody up, because they will take the 1.23 plus 2.81, and they're going to get the wrong value. So my x resultant, which is going to be x1 plus x2, which is going to be 1.23 minus 2.81. That's going to give me a negative negative 1.58. And my y, which is going to be y1 plus y2, and again, both of those are going in the same direction, up. So that's going to be 0.86 plus 1.31. That's going to give me 1.31 plus 0.86, 2.17. And that's going to give me, so my vector is going to go up 2.17, and to the left 1.58. And here's my angle here. So I'm going to figure out what this angle is going west of north, and what my final resultant is. So tangent is equal to opposite time divided by the adjacent. So if we go 1.58 opposite adjacent, which is 2.17, and then you take that value, do the inverse tangent of 0.728. You should have an angle of 36 degrees. So I'm traveling this angle is 36 degrees. I'm running out of room. So let's go ahead and take the figure out the hypotenuse, which is 1.58 squared plus 2.17 squared. That's going to be 7.2. You take the square root of that value, you're going to get 2.68 is my value. So my resultant is, and I'm going to, my answer is going to be 2.68 at 38 degrees west of north. Or if you want to figure out the actual compass heading, you take 360 minus 36, or 324 degrees. And that is how you answer that problem. If you have any questions, let me know, and we'll talk about this later. Thank you.